Most discussions of niacin in the longevity context focus entirely on its role as an ND plus precursor, one path to the same destination as NR and NMEN, with the inconvenient flush as a trade-off. This framing undersells niacin significantly. There is an entirely separate mechanism through which niacin acts, one that NR and NMEN do not replicate, and it operates through a receptor system with implications that extend well beyond cellular energy metabolism. The GPR109A receptor, also designated HCA2, is found on immune cells, adipocytes, and epithelial cells throughout the body, including the gut lining. Niacin binds to this receptor at doses achievable through supplementation, triggering a cascade of downstream effects that are independent of NAD+ synthesis entirely. The receptor activation produces anti-inflammatory signaling, reduction in certain pro-inflammatory cytokines, support for gut barrier integrity, and modulation of immune cell behavior. These effects are real, documented in research, and represent a separate pharmacological contribution that the niacin is just one ND plus path framing completely misses. NR and NMEN do not activate GPR109A. This isn't a minor technical footnote. It means that by choosing NMEN over niacin for NAD plus support, you're not getting an equivalent product with a more comfortable delivery. You're getting a product that is entirely absent from a receptor system with documented therapeutic relevance. For someone with inflammatory conditions, metabolic syndrome, or compromised gut barrier function, this difference is clinically meaningful. The gut barrier dimension is particularly interesting given the current state of microbiome research. A compromised intestinal barrier, sometimes called leaky gut, is increasingly implicated in systemic inflammation, metabolic dysfunction, and possibly neurological conditions. Niacin's GPR109A activation has demonstrated gut barrier supportive effects in animal models and some early human research. Combining niacin supplementation with probiotics may produce a synergistic effect, niacin supporting the physical barrier integrity, while probiotics address the microbial composition. This is a mechanistically plausible combination that NMEN cannot participate in. Emerging research on GPR109A is extending into areas that make the story more compelling and more complex simultaneously. There is early evidence of GPR109A involvement in neuroinflammation, specifically in microglial cell behavior in the brain. There is also preliminary research on receptor activation in certain cancer contexts. These areas are not settled science, and claiming definitive therapeutic applications based on current data would be premature. But they underscore that niacin is doing significantly more than serving as a cheaper NAD+ precursor. It's a compound with multiple distinct mechanisms operating simultaneously, which, in pharmaceutical terms, is typically considered an asset rather than a complication.